small number of cases I know of at least where there's some sort of language-specific property you want to exploit in some back-end code generator or optimizer. Andrew?
I'm just trying to understand. So you described this as a virtual instruction set architecture, but one could also describe it as a universal low-level intermediate representation. And how can we tell the difference?
I think the difference is only in how you use it. It is a universal low-level intermediate representation in the sense that it is the input to compilation phases. Right? But it's a persistent representation. That's the primary thing that we need. It's the persistent representation of code. The reason I think that we can do what there have been previous attempts to develop a universal intermediate representation. I think the reason they failed is because they tried to put too much information in that universal representation. They were trying to record program properties from many different languages directly in the representation itself. We're not trying to do that. In fact, many program properties are left out here. What we're trying to do is an intersection of what I think you need from different languages. Okay,
so I guess just following up on Andrew, if it's going to be a good persistent representation, it needs to be small.
Yes.
It needs to be amenable to the hardware changing it to its own microcode or whatever, however the hardware. Hardware often translates instruction sets as it goes in, into the lower levels.
Right.
And so the question is, how good is it at those metrics?
So I don't really see this instruction set as being something that hardware would directly translate into microcode. In other words, I don't expect that this instruction set is suitable for direct implementation in hardware. You really want a full-fledged compiler backend between this and the hardware itself. And what the hardware sees directly, what the hardware execution engine sees, is really like a standard native instruction set, where it's x86 or Spark or any variant thereof. And those are all that you ever need to actually translate into microcode or microhops. So what you're doing here is doing a standard code generation, just like a JVM does or a static compiler does, except that you're putting certain constraints on making it transparent. It doesn't have to be online, but it has to be transparent.
You're going to have any way to carry, for instance, aliasing information through, let the scheduler have a chance?
We don't directly record aliasing information in the instruction set. We have enough information, you can do alias analysis on it. So we have pointer information, record information, array information.
The high-level language's notion of type system is somehow reflected in the LLVA.
It's lowered down to operations or using pointers, structures, and functions. So for example, if you have an object-oriented system with a virtual machine dispatch, with a virtual function dispatch mechanism, it will be translated down to a virtual function, maybe an array of virtual functions or a structure of virtual functions with explicit lookup and so on.
I'm more interested in scheduling loads and stores by each other, for instance.
Yes.
And so if a store instruction comes along and it refers at the Java level to some field inside some Java structure, I have another load that refers to something nearby.
Right.
Is the LLVA going to be able to tell, and does that require it to have some reflective notion of what Java types are to say these two are unrelated?
I believe the answers are yes and no, that the LLVA compilers can tell, because you can do sophisticated compiler alias analysis on the LLVA representation. In fact, I have a PhD student who's been doing fairly sophisticated typed alias analysis on the LLVA representation explicitly. The second part of the answer is no, because I think there's relatively little information at the Java level that is not available for a reasonable analysis at the LLVA level. Go ahead.
Okay. So one of the easy things that any system can do with alias analysis is exploit the observation that two references of distinct types cannot possibly be the same object.
Yes.
And
we
if
can
you've
infer
lost
that.
a JV, if you've lost a Java type, how do you?
We can infer that. In fact, so maybe what I should do is give you a reference offline to the alias analysis that we use. It uses type information. I'm sorry, what?
You have a magical flow analysis that's so good that it can do anything that you could have learned from the type system.
I would say that we can do anything that we could have learned at the type system. I believe that it's sufficiently precise that you're not losing significant information by doing it on the operational. Effectively, what we have is the operational expansion of the high-level types, right? And I believe that we have enough information that to do it fairly precisely. In the end, the question is, are you really losing? Are you losing information that makes a significant difference to a scheduling algorithm or to a compiler optimization? I think that's really what it comes down to. And for JVM and for MSI, this is something as I said, this is not something that we have data about, but this is something that I hope to show, that I think that it will not make any significant difference.
So I was going to answer your question. I think it's going to make a huge difference because memory barriers are the #1 problem, right? Memory and control flow barriers in scheduling are exactly what you need to overcome. Right?
Yes, I agree.
And you can overcome those with hardware support like speculation and so on, or you can do so using, obviously a preferred mechanism is if you can prove statically or even at runtime that they are disjoint.
Right.
So I think it's critical. Right?
I think the optimizations are critical, I agree.
No, the knowledge, the type-based knowledge is critical.
I think that the difference it will make in terms of the effectiveness of the optimizations is limited. And that's the critical question.
So I mean, I think really the question is what are the right levels of virtualization, right? I mean,
right.
So we have, Java bytecode is very high level virtualization. The kind of virtual machine stuff like VMware is a very low level one. This is kind of in the middle. You also have stuff like Omniware,
right,
which was a little bit lower level. So
I am out of time. Ben tells me I'm out of time. So I might have to perhaps defer this particular question. I can take it. Okay. Try and answer it later on. I'm going to skip. I think I'll just stop there. I just had a summary slide that talked about some of the future research, some of the work that we're doing to explore the benefits of this kind of organization.
Yeah, and why don't you take maybe one or two more questions while Hans sets up.
A less hostile question. So you mentioned, and there's been sort of scattered papers for a long time showing the benefits of persistently caching little bits of compiled code. Yet no production VM does this.
Right.
Why?
That's not true.
Okay, then none that I was aware of until.
So I think there's been a fair amount of work on showing that you can do it, that you can make it transparent. It's not clear to me why commercial VMs don't do it, especially VMs for server applications, like for WebSphere or something like that, where the primary code is more or less permanent and not downloaded applets. I think it's not really clear to me. I think many
The answer
people in
must
the
be
audience
it's
have a
hard,
better
but I don't know exactly why it's hard.
I think there are other people in the audience who probably have a much better idea than I do about why JVMs don't cache this kind of code.
So I know why Hotspot doesn't cache the server compiled code. And that's because it's too closely specialized to the exact dynamic execution pattern. And if you look at the client code, it's too cheap to generate. So now it's a trade-off between exploding in cache from bytecodes to machine code or loading from disk bytecodes to machine code. And it's just as cheap to explode it in your cache as to load it from disk. And you go to the server compiler and you can't do it because of the dynamic runtime.
So obviously, very interesting talk to everyone. Listening. Questions I take offline, I'm sure.
Ben, I'm wondering if you should just capture some of the interesting topics that came. Remember, you talked about using easels, so the type information.
Yeah, I think potentially for a BOF tonight discussion,
Right, so
we probably can fill up at least 3 hours.
Do you want to do it now?
Just put
write
a
a note.
one-word sum, like level of abstraction of types for low-level VM or something like that.
How's that?
Yeah, that's great.
Okay. Okay, it's a great pleasure to introduce Hans Bohm. Obviously, everyone's familiar with Hans as we work with conservative garbage collection.